Hello there. Yes, today we'll be discussing one aspect of solar energy system, and it's a process that is always applied when a panel is being tested, and that's what determines one, the efficiency of a solar panel. It doesn't determine the efficiency of a solar panel, it determines the wattage of the solar panel, and at the end of the day it determines the overall performance of your solar panel. So we'll be talking about there's a term called irradiance. Let's say solar irradiance. Then another one is solar irradiation. This is also known as insolation. These are two terms used for solar energy system, but they have two different meaning. Yes, both of them are related, but they have two different concepts. So for solar irradiation or irradiance, solar irradiance gives you an insight into the power from the sun in a square meter. Okay, this is what it means. If I have a space, this is a square meter 1 by 1. The power from the sun the power we can get as electricity from this space is what this solar irradiance means. It means that if this is a sun hitting this space 100%, the power it can produce on a good day is what this solar irradiance means. So let's go for the solar irradiation. So for this, we'll say this irradiance equals to power per meter square. That's what the irradiance means. For irradiation is the same thing. The sun rays hitting the surface in square meters, but over a period of time. So this has to do with energy, meaning the irradiance hitting the surface over a period of time. So we have P times H meter square. So you can see, so this gives you the power hitting a surface per square meter, but this gives you power times time, meaning if this power is hitting the surface in 1 hour, what is the total energy we get? If it's hitting the same surface in 2 hours, what is the total energy? In 3 hours, what is the total energy? That is what solar irradiation means. The sun power hitting a surface, a square meter as a standard over a period of time. So it's measured, the unit is watts per meter square for solar irradiance, while for irradiation is watts hour per meter square. And we also understand that the higher numbers has to do with kilowatts. So if it's in 1,000 kilowatts per meter square, then this one kilowatts hour per meter square for irradiation. So how much power is striking a surface at a specific moment? That is what this irradiance means. So on a clear day, for example, a clear day, the solar irradiance is 1,000 watts per meter square on a clear day. Yes, when you have the temperature is cool, the sun is hitting the surface, the irradiance is around 1,000 watts per meter square. It therefore means that if this 1,000 watts per meter square hits the surface for a period of time, say 6 hours, so we'll have 1,000 times 6 per meter square, which is equals to 6 kilowatts hour per meter square. How do you write 6 kilowatt hour? This is 6,000 watts hour over meter square. So when we convert this to kilowatt, it gives us 6 kilowatt hour per meter square. It means that the energy you can get from the sun hitting this surface is 6 kilowatt hour per meter square. And this also describes your peak sun hour. How do you explain your peak sun hour? It's using this information. By this information, you can get your peak sun hour. So now, with this information we've gotten, our irradiance at STC, standard temperature condition, is 1000 watts per meter square. So with this value now, let me tell you something. I can arrive at the efficiency of my solar panel if I know its wattage. So we'll use one panel for an example. Let's say it's 720 watts solar panel. Jeho bifacial. Jeho bifacial 720 watts. Let's get the specification of the panels So I just need only two information for now. Let me get the efficiency of the panel. Module efficiency. The module efficiency for this 720 watts is 23.18. That is the efficiency of the solar panel at STC, 23.18. So now, how do I know how they arrive at this information and if it's correct? So let's take also the dimension of the solar panel. Dimension. So the dimension is 2.384 by 1.303, then by the 33 mm. So this is in meters, this is in meter, this is in mm. So I convert this to meters. So now this is the dimension of a 720 watt solar panel and 23.18. So now I want to show us how did they arrive at the wattage of the solar panel. All right, so we have gotten the information for our 720 watt Jeho solar panel. 720 watts, the efficiency is 23.18, and this is the dimension. So what's the square meter of the panel? 720 watts. What's the square meter? Square meter will multiply this by this. So 2.384 by 1.303 equals, that is 3.106 square meter or meter square. So that is the square meter of this panel. So now, if I'm given this information, this 3.106, I can use it to determine the watts of my solar panel. Or if I'm given the efficiency, this is in percentage, I can use this to determine the watts of my solar panel. Or also, if I'm given the watt of my solar panel, I can use this watt, 720 watts, to determine the efficiency of my solar panel. I can also use it to determine the size of my solar panel with just this information alone. So let's go ahead and prove that. So our irradiance is 1000 watts per meter square, and I have a 720 watt solar panel. So let's determine the dimension or the square meter of the solar panel. Determine the square meter of the solar panel. So here is the question. So we'll now say, okay, 1000 watts will cover 1 meter square, right? It means that 3.106 watts, 106 square meters, 3.106 meter square. What's the wattage? Most of the times when your installers or people that sells panels, you go to buy panels from them, with what I'm going to explain right now, you can know if actually the panel that is sold to you is actually what the manufacturer rated it, because the dimension of your panel will determine the power that it should give out and also the efficiency. The efficiency of your panel determines the dimension of your panel and the power. Then the power of your panel also determines the efficiency and the dimension. So these are what we are going to be finding out now using just this information, 1000 watts per meter square, which is our irradiance. This is standard information. Irradiance at STC. Now these calculations we are doing is based on standard room temperature condition. That's what it means, irradiance at STC. So now, three things we are going to determine. Your solar panel has dimension, which is in square meter or meter square. That is this information here. Now it has the power in watts, and it has efficiency in percentage. Efficiency per meter square. So it has this information in percentage. So now, most panels give you this information. So we are going to use calculation to arrive at those information, and which shows that whatever you are getting should have the same accurate information. So now, if given the dimension, let me just use D and power of your solar panel, of a solar panel, determine the efficiency of the solar panel. So with this information, I can determine the efficiency of my solar panel given the dimension and given the power. So now let's determine the efficiency of the solar panel given the, so now we'll be working with, say, a 720 watts Jinko solar panel. The dimension of the 720 watts is 2.384 meters by 1.303 meters. So when you multiply this by this, it gives us our square meter. The meter square of the panel is this by this, which is equals to 3.106 meter squared. So this is the square meter of our panel, the dimension, and this is per square meter. Now, so we have gotten the power of the solar panel, and I've gotten the dimension. What is the efficiency? So let's prove it. When I prove the efficiency, I will now bring the data sheet and show you what the efficiency is. So efficiency of a 720 watt solar panel with a square meter of 3.106 meter square. So now, this 720 watt solar panel has a square meter of 3.106 meter square. So now, what is the wattage of 1 meter square of this panel? So you have to do the calculations. So 1 meter square x, so x equals to 720 watts over 3.106 meter square. So what answer do we have? 720 divided by 3.106, 231.809 per meter square. So this is the watts per meter square of this panel. So in this 720 watt has a dimension of 3.106 meter square. So in 1 meter square of that panel, in a 1 meter square, this is the power, this. So now to arrive at the standard efficiency of the panel, we will use our irradiance information. So our irradiance says in a 1000 watts, we are supposed to have, a 1000 watts should be gotten from a meter square, right? And that is equivalent to 100% efficient system. So in this type of space, this same also is 1 meter square. It means that if we are getting 231.8 watts, what is the percentage? You multiply 100, 231.8 times 100 divided by 1000, which is equals to 23.181. So, in summary, a 720 watt solar panel has an efficiency of what? 23.18%. So when we go into the technical data sheet of the manufacturer, we can see it there. This is a value here. This is a 720 watt solar panel, 23.18. That is the efficiency. You can see it. Module efficiency is 23.18. So that has been arrived with from this calculation. So now, our second question will be, see, if given the wattage and the dimension and the efficiency, what is the dimension or what is the square meter of the panel? So, given the power and the efficiency, what is the dimension in square meter? So now power is 720 watts, efficiency is 23.18% per meter. This is in meter square. So we'll now go to our standard information. 1000 watts gives us, we can get that in 1 meter square, right? Then 23, which is 100%. Right? So in this same information, 23.18 percentage, what does it give us? What is the wattage? It gives us X, it gives us 1000 times 23.18 divided by 100, which is equals to 231.8 watts. So this is what you can get, 231.8 watts. Now, we have our 720 watts panel. 720 watts panel with X dimension. That is a meter square. 231.8 watts in 1 meter square. That's what we can get. So what is the value? So now 720 watts, we don't know the dimension. Now our wattage from this our calculation is 231.8 is 1 meter square. So when we do the multiplication, it means that 231.8 watts times X equals to 720 watts meter square. So X will be equals to 720 watts meter square all over 231.8 watts. Watt cancels this. So what's the answer? So when you divide that, 720 divided by 231.8, it gives us 3.106 meter square. So this is the square meter of a 720 watt solar panel, and we have done the multiplication already. Let's go back to our, let's see, page 10. You can see it. This is it here, 3.1. We multiply the 2 point something by the other value, 1.303. So that's that for this. So now let's go to the next one. We have determined the dimension, the efficiency. Let's determine the wattage. What is the wattage given the dimension, that is the square meter, and the efficiency of a solar panel? We don't know the watts. So what is the wattage? So let's say the dimension given is 3.106 meter square and the efficiency is 23.18%. So let's determine the wattage. What is the wattage of the panel? So in this case, what we are going to do is this. 1000 watts equals 1 meter square space, which is 100% efficient. 23.18% is what? X. So multiply 23 by this. X equals to 1000 times 23.18 all over 100, which is equals to what? 231.8. 231.8 watts. So in a 1 meter square space, the wattage we can get is 231.8 watts. That is based on the efficiency information we have. So for this 3.106 meters square, it means we are going to have X watts. X watts will be equals to 231.8 watts times 3.106 meters square, which is equals to what? 719.97 watts, approximately 720 watts. So if you can do this calculation, you are sure that the solar panel you have gotten is the accurate panel from the manufacturer. Someone can just supply you a 720 watts and the dimension is smaller than this, right? Except the efficiency information is different also. Dimension could be smaller and the efficiency should match the panel wattage. So with this calculation, you can properly understand if the panels that are being provided is what the manufacturer actually named it. So thank you for this class. So if you have any question, put it on the comment section and follow us and like. Thank you.